Hello, Math 137 friends. Here is section 8.4, the last section in chapter 8. They title it Problem Solving. It's sort of more just a twist on, whoops, hold on, I gotta get this cord out of here. A twist on solving quadratic equations. So let's just backpedal to chapter, let me see, this looks like it would be chapter 6 still. We're gonna solve the quadratic equation x squared minus 11x plus 30 equals 0. Now we have three methods for solving quadratic equations. We can factor if the quadratic equation is factorable. We can always use completing the square and the square root property, and we can always use the quadratic formula. I always try factoring first, especially when it's a simpler problem like this, like the leading coefficient is 1. And if you notice, this does factor nicely. We look for two numbers whose product is 30, but whose sum is negative 11. You should get negative 5 and negative 6. So x minus 5 times x minus 6 is equal to x squared minus 11x plus 30. Now we use the zero product principle, and we set each factor equal to 0 and solve. So the first factor tells me 5 is a solution, and the second factor tells me that 6 is a solution. So therefore, the two solutions to this quadratic equation are x equals 5 and 6. So just a refresher, keeping in mind that this variable has to be the same as what's being squared there. So no matter what I put here, I could change these to p's, and it could be p squared minus 11p plus 30. If I change them to w's, would have to have a w squared here and 11 w's there. Or generically, I could say solve something squared minus 11 times that same thing. Those have to be the same thing. This is itself, this entity on its own, and that's that entity squared, plus 30 equals 0. I would set this up the same way. I recognize 11, negative 11 and 30 as two numbers whose sum can be obtained by adding negative 5 and negative 6, but whose product can be obtained by multiplying negative 5 and negative 6. So we would just put whatever that entity is there, right there. And then this factor would tell me that whatever is here minus 5 must equal 0, or whatever this is must equal 5. And likewise, this factor tells me whatever this is, minus 6 equals 0. So whatever that box is must equal 6. So remember, as long as these match, that's it's in its singleton form, this is itself being squared, then we can proceed exactly the same. All right, so that being said, let's look at this example. Let's suppose I asked you to solve m to the 4th minus 11m squared plus 30 equals 0. Now notice this has a lot of similarities with the previous problem. We have the constant of plus 30 on the end. We have minus 11 times something in the middle. These match. Here's m and here's m's. The difference is this is a power of 2 and this is a power of 4. But notice if we take what's in the middle and square it, m squared squared, we get m to the 4th. So this actually behaves like this previous problem, but what we have inside this box is actually m squared. So I can put m squared here and m squared here, and we have m squared squared, which is m to the 4th, minus 11m squared plus 30. So we actually have this problem. We can just imagine putting m squared in that box, and this factors nicely. We are still going to get the minus 5 and the minus 6 here, but what's going to go here and here? Well, what can we multiply together to get m to the 4th? M squareds. So the product of the first, m squared is m to the 4th, and here we have minus 5m squares, here we have minus 6m squareds for our combination of negative 11m squareds. Now for the sake of this section, this power will always be twice that power. So whatever's here in the middle is what's going to go here and here. And if we multiply what's in the first place positions, that should give us this. But now here's where it comes into to be a little bit trickier. We're going to use the zero product principle. And the zero product principle says either this factor equals 0 or the other factor equals 0. So we have to treat these like little tiny problems at the beginning of chapter 8. We're going to now use the square root property. We're going to add 5 to both sides. So m squared equals 5. M is equal to, well, if something squared equals a number, m is equal to the positive or negative square root of that number. So we have two solutions from this first factor. If m squared minus 5 equals 0, then m is equal to the positive square root of 5 or the negative square root of 5. And over here, we get m squared equals 6. M is equal to the positive negative square root of 6. So therefore, we will have 4 solutions. We have m is equal to negative square root of 5, positive square root of 5, negative square root of 6, and the square root of 6. So there's 4 solutions to that problem. All right, so I'm going to continue on. Let's suppose I'm still going to use this template. Remember, I can put whatever I want in here, and whatever I put here, as long as this is the same thing, but it's squared, this template will always work. So I'm going to say solve this problem instead. Solve p to the 6th power minus 11p cubed plus 30 equals 0. Notice we have the consistency with the negative 11 and the 30. And what I have here, I have p's here and here, and this power is double that power. And for the sake of this section and the introduction to these types of problems, that's how it's going to remain for this section. So this is going to factor nicely. We're still going to have the minus 5 and the minus 6 inside the parentheses as part of our factors. And what's going to go here and here that we can multiply together to get p to the 6th is what this term is in the middle. P cubed minus 5 and p cubed minus 6. So now we have 2 smaller problems to solve. Either the first factor, p cubed minus 5 equals 0, or by the zero product principle, the second factor, p cubed minus 6 equals 0. So now to solve this problem, p cubed is equal to 5. And to undo a square root, we square root both sides. To undo a cube root, we cube root both sides. So if p cubed equals 5, and by the definition of cube roots, p is equal to the cube root of 5. Or we have p cubed equals 6, and p is equal to the cube root of 6. Now remember, with odd roots, we do not use the positive negative notation. So if it was an even root, we would need to use the positive, an even power, thus an even root, we would need to use the positive and the negatives. But with odd roots, there's only one value. So therefore, my solutions are p is equal to the cube root of 5 and the cube root of 6. So let's try another one along these lines. Let's again backpedal and start with a basic problem. Let's suppose you were asked to solve x squared plus 3x minus 40 equals 0. Now here's a good time to pause the video and try solving this on your own. Again, we have 3 ways to solve quadratic equations. I always try factoring first, and this in fact is factorable. So hopefully you already did this on your own. I'm looking for 2 numbers whose product is negative 40, but whose sum is positive 3. My x will give me my x squared plus 8 minus 5. Does that work? Negative 40, the product of the lasts give me negative 40. The inners and the outers give me positive 3x. So now this factor tells me that x plus 8 is going to give me one solution, and this one's going to give me that x minus 5 will provide me with the other solution. So one solution is negative 8, and the other solution is 5. Now, when you're solving quadratic equations, as long as you do the math correctly, the answers will always be solutions. Therefore, my solutions are x equals -8 and 5. All right, so now what I'm going to do is to save me the hassle. If I can put anything here, and as long as I put what's here squared here or there, then I'll have this situation, right? We just may have to do further work to find out what's inside the box. So what do I mean by that? Let's suppose I said solve b to the 4th power plus 3b. Well, in order for this to work and follow this format, whatever the power is here just must be double this power. So this is going to be 2. So notice the relationship between those powers. Minus 40 equals 0. So again, we see this relationship with the 3 and the minus 40. So I know that this is going to be plus 8, and it's going to be minus 5. So what's going to go here and here is the smaller of the powers, or what's being squared to get b to the 4th. So what goes here, what we multiply, the product of the first must give me b to the 4th. So b squared is a logical thing to put there. So let's see, b squared times b squared is b to the 4th. Positive 8 times negative 5 is negative 40. Here we get 8b squareds minus 5b squareds. So it's a positive 3b squareds. Now this is a little bit trickier because we get b squared plus 8. This factor tells me that b squared plus 8 equals 0. And this factor says the other solution will be provided by this little tiny equation. All right, so let's go to this guy. This is screaming square root property because we have something squared plus a number. I can bring that number over to the other side. So b squared equals -8. So if something squared equals a number, then that something equals the positive or negative square root of that number. Now a negative under a radical corresponds to an I out front. And then we also have to remember that we have to simplify the square root of 8. The square root of 8 is not simplified because 8 has a perfect square factor. So it's going to be the square root of 4 times the square root of 2. And we get b is equal to positive or negative 2i square root of 2. So there's 2 solutions. Your solutions can be imaginary. If Alex doesn't give you the option to use I, and it has the option no real solution, and you only get i's, that's what you would check. So over here, b squared minus 5 equals 0 means that b squared must be 5. Something squared equals a number. Then that something is equal to the positive or negative square root of 5. So therefore, my 4 solutions are negative 2i square root of 2, 2i square root of 2, negative square root of 5, and square root of 5. Oops, sorry, I'm a little off right there. So look for patterns here. All right, so I'm going to add a little tiny twist into this. I'm going to say solve x plus 3 square root of x minus 40 equals 0. So it looks like we really took things up a notch here. This really isn't all that terrible though. We still have this relationship between positive 3 and negative 40. So what I'm looking for, and these all factor nicely in this section, I'm going to have positive 8 and minus 5. The tricky thing is, what do I put here and here such that when I multiply it, I get x? Well, if we go back and look at the pattern, when we did this, we had b squared here, and we had b to the 4th here, and when we took this term in the middle, the smaller one, and we put it here and here, we notice that when we multiplied those together, we got this. Well, this actually follows that same template. I'm going to take what's here in the middle, I'm going to put it here and here. And let's check out what happens if I multiply the product of the first. The square root of x times the square root of x. There it is. There's my x. 8 times negative 5, negative 40. Here I have 8 square roots of x, and I'm taking away 5. I get positive 3 square roots of x. So if you have a square root here and a regular x there, you're going to have the square roots inside your factors. All right, square root of x plus 8 using the zero product principle. The first factor equals 0, or we're looking for numbers that make the second factor equal to 0. So to solve a radical equation, we isolate the radical, then we square both sides. So we get x equals 64. Over here we get the square root of x equals 5. We're going to square both sides. X equals 25. All right, so now these are, things change up a little bit here. These are possible solutions. Because we started with a radical equation, you must check the original equation to see if they are actual solutions. Always, whenever you start with an equation that involves a radical, you have to check the original. So let's go to x equals 64. Is it true that 64 plus 3 times the square root of 64 minus 40 equals 0? Well, 64 plus 3, the square root of 64 is 8, minus 40 equals 0. Does 64 plus 24 minus 40 equals 0? Well, 64 plus 24 is 84 minus 40. 44 does not equal 0. So this is what we call an extraneous solution. It was a solution to the revised equation, but not to the original. So you only have to check that your solutions are actual solutions if the original equation involves a radical. So 64 solves the revised equation, but not the original. So that's an extraneous solution. So let's check the other solution, 25. So if x equals 25, we plug in 25 wherever we see x. Is it true that 25 plus 3 times the square root of 25 minus 40 equals 0? Well, 25 plus 3 times 5 minus 40 equals 0. 25 plus 15 minus 40 equals 0. 25 plus 15 is 40, minus 40, 0 equals 0. So that is a true statement. Therefore, my only solution is x equals 25. So remember, if you start with the radical equation, you have to check the answers. All right, that's it. Nice short section, kids, to do. Read 8.4 in the text. Exercises 1 to 17 odd, 41 and 43. Alex. Today is, let's see, so 8.1 to 8.4 topics. You have all the information to complete all the topics in Alex now. So your schedule of times. So today, let me see, so for 4-8, 60% plus or 5+ hours. So for 4-15, you should be at 100% or 5+, oh, nope, no, 100% because you have a test the next day. So let's get rid of that. Chapter 8 exam on Thursday, 4/16. Same process as last time. It'll be open from 8 to 8. You'll have 2 hours to take the test. But super importantly, you need to download. Only about half of you have done this. The lockdown browser And this time we added the Respondus monitor. You must do this by Tuesday. By Tuesday, 4/14. I cannot be dealing with technical issues in the hours leading up to the exam. I've given you 2 weeks to do this, so please get on this. These exams have to be videoed per discretion of my department chair. It's not an option. So please get on this. And that's it. Chapter 8 is done. And we will start Chapter 9 lectures in a few days. All right, hope everybody is well and safe. Talk to you soon. Bye-bye.